then we continue with our class. So the scope, I think, for quiz number 2, it's going to be chapter 4, and then I think in part of chapter 5. That means whatever we're going to do today is going to be included there in the scope of quiz number 2. So whatever we're going to do today is very important for the quiz. Okay. So let me just go to the window journal. Okay. Let's go there. There we are. Okay. I think it's lecture number 15. And we are in chapter 5. Chapter 5. And chapter 5 is about estimations. 3 estimations. Number 1 is ratio. Number 2 is regression. And the last one is difference. Difference estimation. So that's chapter 5. So we are going to talk about ratio, regression, difference estimations. So today we're going to start with the ratio estimation. Start with the ratio estimation. So for those who are having a lecture notes, it's on page just look, page 35. It's page 35. Now, let's start. Let's suppose you have a box. Okay. You have a box full of oranges. Okay. You have a box full of oranges. Let's say this one are oranges. Okay. And on the orange, there is a sugar content there. And then plus a weight. Okay. Now, the whole price of that box, that contains oranges is based on the sugar contents of the load. What I'm saying is that I can just use another color here. The whole price of that box of oranges is based on sugar contents of the load. I think we agree on that. Okay. Just go down a bit. Now, Let's suppose that we have got a y variable. Let's suppose you have got a y variable, and that y variable represents the sugar content. Okay. Content. Okay. And we have another variable called x, and in that case represent the weight. The weight of the orange. Now, you can tell me the total content will be abbreviated as what? So the total, let's say the total sugar content, so to speak. Content can be abbreviated as what? Star Y, isn't it? Agree? And remember, to calculate the total, if you still recall, if you apply some information that I gave you before, it's equal to the population size multiplied by the mean of that sugar content. Okay, that is the total sugar content. It's equal to tau y, which is equal to the population size multiplied by the mean of that sugar content. What about the total weight? The total weight will be represented by what? Tau x, isn't it? Which is equal to what? N mu x. Okay. Think we are together. Then, if you want to divide the total sugar content by the total weight, we are going to have the total sugar content, then you divide it by what? The total weight. What did you get? In other words, it's tau y over tau x, isn't it? It's tau y over tau x, which is equivalent to what? Tau y is equal to n times mu y. Okay, and tau x is equal to n times what? Mu x. Okay. Then this goes to the sea, this one to the ocean. Then we're left with what? Mu y over mu x. Okay. Now, if you want to find the total sugar content, what do we do? So in this case, let's say we are interested in the total sugar content. So you are going to have what? Tau y, which is equal to what? Mu y over the next piece. Sorry for that. Need the space. So let me just take it down. Total sugar content, which is tau y, will be equivalent to what? Mu y, isn't it? Divided by what? By mu x, then multiply by what? By tau x. Okay. So this is the total sugar content. Okay. So you can just say total sugar content here, so that you can remind. Sugar content. Okay. Where in this regard, where mu y divided by mu x represent what? The population ratio. And the population ratio is abbreviated as what? SR. So that is the population ratio, that one. So this is the population ratio. That's R. Okay. In other words, if you want to calculate the population ratio, you must know that you have to divide the mu y by mu x, which is the mean of the sugar content divided by the mean of the weight. Okay. So now, if you want to estimate the population ratio.
Good morning, sir.
Okay.
Yeah, I couldn't get the part where you divided the total sugar content and the total weight. Why are we dividing, sir?
No, the main idea here, we just want to come up with the formula that you can use to calculate the what? The total sugar content. The total sugar content is like that. We just want to calculate the total when we are applying the what? The ratio estimation. If the question says, okay, calculate the total something there,
Or
when we are
using the
using
ratio?
the yes. That's the main idea.
Okay.
So that is why at the end of the day, we have this formula here. Okay.
Oh, all right, sir.
So what I'm trying to do is to summarize what is there on the lecture notes. If you can go to the lecture notes, you find something there. But they use the what? The apples. They use the apples instead of the oranges. In my case, I use the oranges so that you can understand what is happening. Okay.
Good
Now,
morning.
if you just want, okay, if you
Can
want
you
to estimate, or let's say we want to find the estimate of the population ratio. Remember, I said this one represent the what? The
Sir?
population ratio. Yes?
Can you please go up a little bit for a second, please?
Okay. Up again here.
Again.
Yeah.
Thank you. Thank you.
Okay. You're done. Okay. So now let's find the estimator of the population ratio. The estimator of this. Okay. When you talk about the estimator, let me just write it down so that you can remember it. Estimator.
Yes, sir.
Yes.
Which I want to ask, can you please go up a little bit?
Okay. Yeah, or down again?
Yeah, it's fine. For the total sugar content for the Y,
Star Y. Yeah.
you say it's equals to N
Times mu Y.
mu Y. Then go down a little bit.
Again?
Yes. Yes, here. It's the Y again. You're saying it's mu Y over mu. It's mu Y over mu X multiplied by
tau X.
Tau X. So it means the right hand side is also equal to that one on top of.
Yeah, it's the same thing. It's just because here we want to find the tau Y as the subject, the formula. Here, up there.
It's the same thing.
coming from this part. You take this multiplied by this, take this multiplied by this.
It means I can say n is equal to tau x over mu x.
N equal to tau x over here is n over mu y over, is it
I mean
n
from
mu y?
from the first one.
Oh, here
Yes, and the last
and this one.
no, and the last one.
Yeah. Oh, yeah.
Of tau.
Okay. Yes. Total sugar content is equal to this one. Okay. And again, total weight is equal to this one. Okay. So if you want to divide the total sugar content by total weight, this is what we did, isn't it? Then we find this one. Okay. So then from here again, you can find that. So in other words, this one and this one, okay, there are two formulas that you can use to calculate the total sugar content. In this regard, it's when you have got the weight. You see that you have got the weight there, total weight, but here you don't have a weight there. Okay. So in this case, so that means if you have got the weight, so you are supposed to use this one. If the weight is not given at all, but you have been given the population what? The population size, so you can be able to find what? The total sugar content. But however, if the population size is not given, but they gave you the total weight, so you can be able to use this one. So you will see when we do the example where we don't have the population size, how are we going to solve that one? So all of them are okay, are fine. There's no problem with that.
All right, thank you.
Okay. Now I wanted to say that we just want to find the what? The estimator of the population ratio. The estimator of the population ratio. What does that mean? The estimate of the population ratio is like we want to find what? R estimate, isn't it? Okay. If you want to find R estimate now, you are going to say R estimate is equal to small r. That small r shows that is an estimate of the what? Of the population ratio. And it's equivalent to what? To y bar over x bar. Okay? Which is equivalent to what? You know that y bar is what? Summation of y over n, isn't it? Divided by x bar is summation of x over n. You know that. Which is equivalent to what? To the summation of y over summation of x. Are we together? So if you want to estimate the population ratio, you can use that formula. R hat, which is equal to small r, which is equal to y bar over x bar, which is equivalent to summation of y divided by summation of x. Okay. So now, if you want to find the estimated variance of that estimator, in other words, the estimated variance of the estimated population ratio, okay? If you want to find the estimated, I just want you to write it down in words so that you can follow. Estimated variance of the estimated population ratio, which is R, isn't it? So you use what? You use the var estimated of what? Small r. So this is the estimated variance of the estimated population ratio, which is abbreviated as what? Var estimate of small r. So, and it's given by population size minus the sample size divided by the population size, okay, multiplied by 1 over mu x squared. See that one? Then you multiply by what? SR squared over N. So SR squared is the sample variance under ratio estimation. So I will show you how to calculate that one as well. So the estimated variance of the estimated population ratio is equal to N minus N divided by capital letter N multiplied by 1 over mu x squared times SR squared over N, where SR squared, which is the sample variance under ratio estimation, where SR squared is equal to the summation of yi minus r times xi all squared divided by n minus 1. Okay, this is the simple variance under ratio estimations. Summation of yi minus r times xi all squared divided by n minus 1, which is also equivalent to the summation of yi minus summation of y over summation of x, okay, xi all squared divided by n minus 1. So we can use this one or that one. So in other words, for the first one here, so you use it if you have got a ratio, estimated population ratio. And this one, you can use it if it's not given, but you have the summation of y and summation of x. So you can use it that way. So, yes.
On the summation of y divided by summation of x is multiplied by what? Mu.
Xi, this one.
Yeah.
Xi.
Oh.
Sorry, it's not mu, it's xi. It's coming from this one. This one. The
Oh,
only
yeah, I
different
see.
here. Yeah.
I see.
Now, so let's estimate the population mean under ratio estimation. Okay. If you want to estimate the population mean under ratio estimation, so in other words, we are going to have the ratio estimator of a population mean, mu1. In other words, we're estimating the population mean under ratio estimation. Okay, sorry. So, in other words, you're going to have what? Mu hat y, because you are estimating it, isn't it? Which is equal to what? Y bar over x bar times mu x, which is also equivalent to what? To summation of y over summation of x times mu x, the same thing, which is also equivalent to r mu x, is the same thing. Okay. So it's when you want to estimate the population mean under ratio estimations. That's why we call it a ratio estimator of the population mean, mu1. Okay. Now, what about the estimated variance of that estimator? The estimated variance variance of the estimated population mean under ratio estimation, in other words, of mu y. So it's like it's the var estimate, mu y estimate, okay, and it's equal to n minus n divided by n. Is r squared over n. That is the estimated variance of the estimated population mean under ratio estimation. So, but if you want to find the variance of the estimated population mean, remember this one is the estimated variance of the estimated population mean. Okay. So, but now let's say you want to find the variance of the, so you can just say of the estimated mean, variance of the estimated mean, the same thing. Okay, so that means you're going to have what? Var of mu y hat, isn't it? Which is the same as what? N minus n over n minus 1. Then you close the brackets. Then you multiply by what? The variance. It's no longer s now, it's sigma squared r over n. Okay. So that is the variance of the estimated population mean under ratio estimation. Is the var of mu y hat, which is equal to n minus n divided by n minus 1 multiplied by sigma squared r over n. Now, what about the ratio estimate of the population total? In other words, is the estimated population total under ratio estimation. Call it ratio estimator of a population total. That is what? Tau y. Okay. So it's what? So it's what? It's tau y estimate. Okay. Which is equal to what? Y bar over x bar times tau x. Okay. Which is equivalent to r tau x. This is the what? The estimated population total under ratio estimation, or it's the ratio estimate of the population total, which is the same as the ratio estimate of the what? The sugar content, total sugar content, isn't it? So now, what is the estimated variance of that estimator? Estimated variance.
Sir,
Yes.
what is that thing you wrote after R, sir?
Yeah.
Yes, sir.
It's tau x. It's tau x. The same thing. It's the same thing as this one. Then. The same thing as this one. The only
No,
difference
it's just
here
like
you're using
it just like
y
it's
bar.
just that it looked like a 2C or something.
This one is the same as this one. This one is tau x. This one is tau x. The same as this one. The estimated variance of the estimated population total of this is our let me use the same color here. Okay, so you're going to have what? Let me use it here. Var estimate of tau y estimate close brackets, which is equal to n minus n, then SR squared over n. So now, in this regard, it's when you have got the population size and the sample size. So for in case when you don't have the population size, you're going to use this formula. Tau, tau x over x bar, okay? Open brackets, tau x over x bar, then minus n, then times SR squared over n. Can you see the difference here between this one and this one? The first one here is when you have got the population size. So that is why we are having n open brackets n minus n close brackets, okay? The second one here is when you don't have the population. If the population size is not given, so you can use what? The total weight, which is tau x divided by x bar. The x bar stands for the average, okay? And in that case, if the average maybe is not there, but they gave you mu x, so that means you can substitute x bar by mu x. But if x bar is there, so it's tau x over x bar, open brackets, tau x over x bar minus n, close brackets. Are we together? So I think this is the theory behind ratio estimation. So now we can just quickly go to the example and see how can we apply these formulas. Any question? Okay. If you can go to lecture notes, I don't know whether I can just project you. Yes.
Can you please repeat what you said about the two equations?
The last two equations. Okay. I was saying this is the formulas that you can use if you want to estimate the variance of the estimated population total. Okay. So the first one, you can use it if the population size is given. In other words, if big N is known, okay, it's given. So you can use this one, the first one, okay. However, if the population size is not given, if N is unknown, so you can use the second one. In other words, you're going to use tau x over x bar, open brackets, tau x over x bar minus n close brackets SR squared over n. Okay. And again, there are some cases where you find that maybe x bar is not there, but they give you what? Mu x. Okay. So you can use this one instead of this one. Okay. But if both are given, so you have to use this one, like what we did here to divide by x bar. We use mu x if provided x bar is not there and the population size is not there. I don't know whether it's clear. Okay, let's go to the example then. Example is on page 39. started there. Okay, let me just try to see whether I can project it here. Let me see whether I can show it here. It's on page 39. Let's go there. It's on page 9. Yes, there we are. Let me just try to make it big. See, this is the example that we're talking about. Okay, so let's try to read it a bit and analyze it. Like I said, here they use the apples and we have used the what? The oranges. They're saying, yes, Makualele. You raise your hand. Is it a mistake? Well, okay. So as it turns out in this example, we've got this example 5.1, where we have got 15 apples selected by simple random sampling. 15 samples. What does that mean? It means that our sample size is what? Is 15, isn't it? Okay. Where were weighed and also juiced. So in this regard, they have, let me just go down so that you can see what is happening. In our case, we use the total sugar content, which is tau y, or maybe the sugar content, which is y, but here they use y as what? As the weight of the apple juice. You see that one? C2. It's y, which represent the weight of the apple juice. That's y, according to them. And here they use x as weight in the apple. And in our case, we use y as what? Sugar content, and x is weight. So that means x, in our case, is weight of an orange. In their case, x is the weight of the apple. So it's okay. But the difference is on y, because they said y is the weight of the apple juice. In our case, we said is what? Y is the sugar content of the orange. Okay. So you have to see the difference between those two. But it's the same thing anyway. Let me just go up. There is this guy called Makualele. He has raised the hand. What is your problem, sir? Okay, thank you very much. So I said a sample size is 15. Okay. Now they said that the total weight of an apple shipment was found to be 2,000 pounds. The total weight of the apple, in our case, is a total weight of what? Of oranges was found to be 2,000 pounds. What is that? Who can tell me what is that? Is it tau y or tau x? Yes, that is our tau x. Thank you very much, Aaron. So that is our tau x. So in other words, we have been given the information of a sample size, which is 15, and they gave us the information of a what? the total weight of apples or of orange, which is 2000, which is tau x. Okay, let's go down and see the questions down there. There's some question down there. Next page, I think. Page 40. If you check page 40, there's a table there. Table shows the y variable and x variables. And then they calculated y minus rx and y minus rx all squared for you. Then later they done it, and then they input there using Minitab. Okay, and then s, which is 0,0185258. That is the standard deviation or under ratio estimation. In other words, it's SR, which is 0,0185258. So in other words, you have to find the simple variance there. Simple variance is going to be SR squared, which is, let me just show you what I'm talking about here, which is 0,0185258 standard deviation. So you have to square it so that you can have a simple variance. Okay, so let's go. So then statistics there, they calculated mean for you, standard error of a simple mean, standard deviation, quantile 1 and quantile 3, and the median, everything. So now if you check, they use capital letter N there. You see that one? Let me just go there. Here, they use capital letter N. It's an error. It's supposed to be a small letter n. That is a sample size. It's not a population size. Are we together? So that one is represent small letter n, which is a sample size. Sample size is equal to 15, not a population size of 15. So it's 15. And then they calculated the mean for apple juice and the weight for apple juice and everything. So let's go to the question down there. It says use ratio estimate to estimate the total weight. I think there is a missing information there. So you have to estimate the total weight of apple juice. Total weight, yeah. Here is the total weight of apple juice. Okay. So in a case, it's not an apple juice, it's what? It's the total sugar content. It's the total sugar content. And the total sugar content is what? Is tau y. But we're estimating it. We need to find what? The estimated tau y is the same as the what? The apple juice there. It's total weight tau y. It's what we wanted to calculate. Then from there, they say calculate the estimated variance of that estimator. So in other words, you have to find estimated variance. Var estimate of that estimate. That's it. Then later you have to place a bound. Okay. So you know how to place a bound. Now let's quickly go and our time is it up? Yeah, okay. Since our time is up, let's say just go and
Yes, sir.
on.
Yes, sir.
Then we are going to finish it up on next time.
So, say,
But eh?
say,
Yes, yes.
when can we expect to get our quiz result?
Oh, the marks.
Yes.
later today or next week, Monday. Or
Okay.
if I will be working during the weekend, I might send them during the weekend. But I'm done. I'm just left with some simple things, technicalities.
Okay, no problem. Thanks.
Okay, sure. So let's stop here, and then we are going to meet when Thursday, and then we are going to continue with this example, which is part of this